Okay, welcome back. So this is P14, which is the particle model. Okay, so you should know from primary school or from your chemistry lessons, okay, these three states of matter, okay, solid, a liquid, or a gas, and the atoms are arranged accordingly. So in a solid, they're arranged in a regular repeating pattern, like you see here. Okay, in liquids, they're still touching each other, they're close, but they're not in a regular pattern, okay? So they're literally, because they've got a bit more kinetic energy, so their intermolecular bonds are sort of simultaneously breaking in some parts and then rejoining in other regions, okay? So that allows the atoms to move past through each other, okay, or over each other. Whereas with gases, literally, they've got so much kinetic energy, okay, that their intermolecular bonds are literally all broken, and they're free to spread out and move in different directions, okay? So just to make sure, you know, there are really strong bonds in between the individual atoms in a solid, which means that ensures that it's structured in that way. In a liquid, yes, there are bonds with most of the neighbors. As I said, we've got this simultaneous action of the bonds being formed in some regions of the liquid and then them being broken in other regions of the liquid, okay? And there are no bonds at all in the gas, okay? So, you know, I've talked about all these points, okay? So they literally, in a solid, the atoms just vibrate in a fixed position. The particles in a liquid can move or flow past each other, and then the particles in a gas literally are so fast that they literally move all over the place. So let's look at this equation, which you've got to remember, and its density is equal to the mass of that substance divided by its particular volume. Okay, density is units of kilograms per meters cubed. Okay, mass in kilograms and volume in meters cubed. For your exam, okay, like always, I've said this in lots of videos prior to this, you've just got to be able to rearrange this equation, okay, put it in a triangle if that's going to be useful to you, okay, that means you're going to have D times V on the bottom and then M on the top, okay, so you just block one out, and so if it was M, it's going to be D times V. If you covered up D, it would be M divided by V. If you covered up V, it would be M divided by D, okay? So what does density mean? Well, it's essentially, it's the concentration or the ratio of the mass in that particular volume, okay? So a high density would mean a high mass in a small volume, low density would mean a small mass in a large volume. Okay, so how would you calculate density? Well, obviously you need to measure the mass using a weighing scale. Okay, you can calculate the volume of a cube with a ruler. Okay, measure the respective height, width, and length. Okay, once you've done that, then you just need to multiply the respective lengths, and then you'll get a meters cubed value. Okay, that's going to be your volume. To find the volume of an irregular shape, you need a displacement can. Okay, so essentially these are, sometimes you call them a eureka can, but essentially they're just a can with some sort of nozzle on one of the sides, and obviously you fill it up with water, and then you place until all the water comes out of that spout, and then obviously you place your irregularly sized object inside that displacement can with a measuring cylinder outside that nozzle, okay, of that can, and then you can then measure the respective water that gets displaced, and that's going to be your volume, okay? So solids have the highest density and gases have the lowest density. Okay, you should know that from everyday life. Okay, if you hold something, you know, a solid object, that's generally more heavier than if you just placed your palm in the air and you just weighed the air with your hand. You obviously would know that the air is less dense. Okay. So why is that the case? Well, essentially they've got the same amount of particles, okay? Just in the gas, the particles are more spread out, so they've got a larger volume, okay? But both have the same mass. So let's look at this diagram now. We've got temperature on the y-axis, and we've got energy on the x-axis, okay? So here we go. As temperature increases for this solid, okay, so that we start off with, okay, the amount of energy being passed onto, let's say we're heating up this solid, okay? Say, I don't know, it's some ice. We're passing some energy onto the particles. They vibrate, you know, even more as more energy is being passed on to them. Okay, and then it comes to a point where the temperature remains stationary. Okay, does not change. That is the melting process. That's the changing of state. Okay, so this is when some of the bonds are broken. Okay, which will cause that state to become now a liquid, which means the atoms have the freedom to flow past each other. Okay, so again, we're gaining temperature, we're gaining a thermal energy, which will be converted into the kinetic vibrational movement of the particles, and then we get to this stage here, which is the boiling point. Okay, again, changing of state from the liquid to the gas, and again, all the bonds are broken at this point, and the temperature does not change, and then we have our gas. Okay, and then the gas particles move even further apart depending on how much energy is passed on to them. Okay, so for your exam, make sure you're able to describe this process. We can have the same thing going the other way as well. So again, if we cool down a gas, okay, put it in a refrigerator or in some cold environment, okay, we get this process called condensation, okay, where the temperature does not change, and this is when bonds are being formed again, okay, so that we change state from a gas to it becoming a liquid. Okay, so we're reducing the energy here, okay, and then we get freezing here, okay, so a liquid becoming a solid, and again, the rest of the bonds are forming again because we're losing thermal energy, okay, and then we come to our strong solid where all the bonds are formed and the atoms are in that regular pattern. I suppose the last thing to mention with changing of state is that it is a physical change, okay, so it is reversible. Okay, so we can go, as these graphs show us, we can go either way, okay, and it is a physical change. It is not a chemical change, okay, so let's say we started off with H2O water. We will still return to that same chemical formula of H2O, so it is not a chemical change. So a chemical reaction is not taking place when we heat up or cool down the H2O. It's just a physical change, okay? And depending, let's say we've lost no mass, okay, through the heating process going this way and the cooling process this way, we could say that the mass of the liquid should be equal to the mass of the solid that it was made from, okay? If none of the material escaped during the heating and the cooling of that original solid.